Hi guys, in this video we're going to see polynode analysis using nodal analysis. So here's the circuit we have. I think it's pretty simple, but lots of people have a problem with these kinds of circuits. So the steps that we're going to follow is identify the nodes. Now just the important nodes that have 3 or more connections, and write the equation for each node current and solve using matrix or whatever you want, and then compute the requested parameters. So in this problem we want to find out the current through the 5K resistor. I've written that as I, going from up to down. Okay, so now first step is identify nodes and label them. So I've got V1, V2, V3, and V4. And then we're going to set a reference point. So I'm going to say V4 is a reference. Now we could have chose any node, but that's just the one I used. So now we're going to see we're going to go through node V1, V2, and V3 and find the equation for each node current and set that equal to 0. So V1 is V1 minus V2 over 2K plus V1 plus 5 volts minus V2 over 1K plus V1 minus V3 over 8K plus V1 minus 10 volts minus V3 over 7K, and that's equal to 0. So you might be wondering or have a hard time remembering whether or not to use plus 5 volts or minus 5 volts when going through a voltage source. So the way I remember it is out is positive for me from node V1, let's say. And if I enter the positive side of the terminal, it's going to be minus. And if I enter the negative side of the terminal, it's going to be plus. So that makes it just easy. Do the same thing every time, and you're less likely to get confused. So then for node V2, we have V2 minus V1 over 2K plus V2 minus 5 volts minus V1 over 1K plus V2 minus 20 volts over 6K plus V2 over 5K, and V2 over 5K is the I that we want to find out, and we set that equal to 0. Set the entire equation equals 0. Now for node V3, it's V3 minus V1 over 8K plus V3 plus 10 volts minus V1 over 7K plus V3 over 3K plus V3 over 4K, and that's equal to 0. So I have a very nice calculator that I don't need to do all the steps, put it into matrix and all that stuff. So I just type in a bunch of things and then I get my answers. So I got V1 to be 5.5947. Let's round it to 3 sig figs, so 5.59, and I've rounded the other 3 to 3 sig figs as well, so 8.96 volts, and V3 is 0.0823 volts, or 82.3 millivolts. Okay, and then compute I, which will be 8.96 over volts over 5K. Now, whenever I say K, I mean kilo ohms. That's just the way I write it. And yeah, it seems to work out for me, and I'm going to get milliamps as my answer. So 1.79 milliamps. I've written 9.2, but 3 sig figs is fine. Then I'm going to check my answer against a circuit simulator, and lo and behold, all of the answers are correct. So I'm 100% confident with my answer. And that's how I approach doing a 3-node circuit problem like this. I always use Nodal because if I use the same thing every time, I won't get confused and make a mistake. You can use this to solve simpler problems or even more complicated problems. And we will see in a later video that you can use this method with dependent voltage and current sources as well. It's not really an issue. Okay, that's it. The end of the video. Thank you very much. Bye for now.